Hello, 7th graders. Today's lesson is 2.4 and 2.7. It's a little mixture of both metabolism. And your learning targets for today, I can use data to diagnose Elisa based on her levels of oxygen, glucose, and amino acids in her body. So the last couple lessons that we've done, we've really taken a look at 4 different medical conditions, and we've learned as much of those as we possibly can. Today we're really going to dig in to the actual data to diagnose Elisa today. So you guys are going to get some answers today as to what is really going on with Elisa. And with that being said, we're also going to be kind of finishing up chapter 2. We're going to skip obviously a couple lessons in there with the exception of the critical juncture, which we will do in our next lesson. Okay? All right, first thing you guys need to do today is activity 1 notebook. You need to open up your OneNote and add key concept number 7 to the key concepts page of your notebook. So key concept 7 says, a problem with the body system can result in fewer oxygen, glucose, and or amino acid molecules getting to the body cell. So really that is what we are digging into today, is how that relates to those 4 different medical conditions and specifically what are our levels of each of those 3 molecules. Excuse me. All right, moving on to your warm-up today. So for your warm-up, you guys are looking at an inaccurate model of a healthy body. So you guys will need to right-click and open up this link, and it's going to take you guys into this modeling tool. What you guys have is an incorrect model of a healthy body, and you guys need to fix it, okay? So you guys would kind of look and say, all right, one thing I look at is my little green molecules over here are oxygen. Should I have oxygen in my small intestine? The answer is no. Okay, you don't eat oxygen, so you guys would move it. All right, we breathe that into our lungs, so maybe we drag it over there. So what you guys are going to do is you're going to look around like, oh, how big are the molecules that can fit in our bloodstream? Okay, think about those kinds of things. So if you see something, all right, like this part is starch being broken down into what? Okay, so take a look at all those things and fix them. Okay, if you guys need to add things, go ahead and add things. If you guys need to move things, move them. If you need to get rid of things, go ahead and get rid of them. And once you guys are done correcting the model to the best of your ability, go ahead and take a screenshot of that model and add it right here. Okay, you guys only need to screenshot this little square right here. You don't need to worry about your molecule bar on the right-hand side. Okay, so screenshot that in right there, and then once you guys are done with that, answer these questions. Explain what you changed about the model and why, and then which molecules do cells need to get from the outside of the body in order to function properly. So answer that question using your draw tool there, okay? All right, remember to pause this video as you guys go to complete each activity, and then when you guys are ready, let's move on. All right, so what I wanted to do before we really get into this lesson is review our medical conditions that we should have learned about in the last lesson we did, which was 2.2. Okay, so in 2.2, you guys, and 2.3, you guys really got to dig in and read some articles about the 4 different medical conditions. If you guys were at home doing this, you guys kind of were on your own to figure out all 4 medical conditions. If you guys were in class for that, you guys should have had a chance to talk with your group. Either way, you guys might have some incomplete information, so I really wanted to go through these 4 conditions with you guys and kind of sum up what you guys should have taken out of the article. So the first medical condition that we looked at was anemia. Anemia, the title for that article was red blood cell shortage. Okay, so what you guys see with anemia is you have a lower than normal red blood cell count, meaning that if we were to take a look at a drop of your blood, there's fewer red blood cells in there. And red blood cells really act as like the little taxi that grabs oxygens from your lungs and takes it to the other cells and then picks up carbon dioxide and gets it out of your lungs. Okay, so again, you can think of them as little taxis that carry oxygen around. Okay, with that being said, your patient will breathe normal. Okay, if you have anemia, you're breathing normal, you're getting the correct amount of oxygen into your lungs, but when those little red blood cells go to pick up oxygen from the lungs and the circulatory system, they're just not picking up as much oxygen because there's less of those little taxi cabs. Okay, so the patient will breathe in enough oxygen but will not be able to transport enough to the cells. So we would definitely see our circulatory being affected there. Okay, our respiratory is not affected at all. We're still breathing in the same amount of oxygen, and of course our digestive isn't. affected in this as well. Okay, we're going to see with this a lower amount of oxygen in our cells because there's less oxygen being transported from our lungs to our cells via the circulatory system. Okay, how we can fix this is if you have this condition, you really need to focus on what you eat. So you would need to eat a lot of foods high in iron. And anemia can be a long-term condition, or it could be a day-to-day, throughout the day type of condition where maybe before you've eaten breakfast you're a little anemic, but after you eaten breakfast you're kind of on that borderline and you're all right. Okay, but generally we see people with anemia kind of having it an ongoing thing. They have a hard time making red blood cells and need more iron. Okay, with that being said, need more iron in the diet. So you might find these in dark leafy greens like spinach. Meat of any kind really has a lot of iron. Fortified cereals, so those more dense, I kind of like to think of them as not like Lucky Charms. Okay, they aren't super fortified with iron. And beans, things like that. So you kind of see that same kind of concept with high protein. With the exception of like leafy greens and stuff. So that's good sources of iron for us. Okay. Next condition was asthma. So you guys might be fairly familiar with this one. It is one of our more common conditions that we talked about out of the four. So this is called struggling to breathe. So what we see is for whatever reason a person has asthma, if it's exercise induced or maybe it's something in the air like an allergen that induces it. Okay, we have some kind of irritation in our lungs that causes swelling or constriction, meaning that we can take a breath in, but all that oxygen isn't getting to where it needs to be in our lungs. So we're not allowing enough air into the lungs, so the patient will not breathe in enough oxygen and therefore will not be able to transport enough oxygen to the cells either. So they have a normal number of red blood cells, but they just don't have as many passengers or oxygen molecules to take around to the cells. So you will see your respiratory system being affected here. You'll see your circulatory system being affected here. Obviously no digestive system here as we're dealing with oxygen. And we'll see low numbers of oxygen in our blood as well as in our cells, okay? And in our lungs as well. So basically overall low oxygen, okay? People with asthma sometimes really struggle to breathe depending on how severe it is and how big their attack is. Okay, so a way to prevent this or to medicate this is to avoid irritants. Or if you guys have asthma bad enough, you can use an inhaler with certain medicines or steroids, which help us reduce the swelling of the lungs, so allowing more oxygen in our lungs to begin with. All right, next one. So these next two both deal with our digestive system and the amount of glucose that gets into our cells. So diabetes, again, this is probably one of the more common ones, but maybe you guys don't know as much about diabetes as you think you do. So this one's called diabetes glucose locked out. So what we see is a chemical in our body that's secreted by our pancreas. And the whole purpose of this chemical is to take glucose out of our bloodstream and to put it into our cells where it belongs. So maybe that's glucose storage, or it's just cells in our body where we're using that glucose to make energy. So again, what we see with this is lower than normal levels of insulin. Insulin is a chemical that moves glucose from the bloodstream into the cells for storage or energy use. So the main thing that we're going to see with this is it's going to affect our circulatory system, okay? Our digestion is just fine, so digestive system is not affected with this one, okay? Patient will have high or enough levels of glucose in their bloodstream from normal digestion, but will not have enough in their cells. So basically what happens is and I talked about this in class, is you don't want a lot of glucose in your bloodstream, okay? You need to get that out of your bloodstream and into the cells of your body where you need to use it for energy production, okay? If it stays in your bloodstream so too long, it actually can damage a lot of different places in your body where we shouldn't find glucose. Okay, so patient will have, so again, we're gonna see high levels in the bloodstream generally, and then not enough in our cells. So our cells are just not gonna be getting enough for energy. And we can regulate this with a good diet. Some people who have less severe cases of diabetes or different types of diabetes can, again, regulate with diet. But those who have your typical cases of type 1 diabetes generally has to monitor the blood glucose. Nowadays, there's a lot more of like monitors that attach to your body that can check your blood and even send it to your cell phone, check how your levels of glucose are doing, and then you can take shots of insulin to help regulate if you're too high. you guys old school way is you do is have to prick your finger, take a drop of blood, test it with a little monitor, and then again give yourself a shot of insulin based on how much sugar you had in your blood. So it's changed a lot as far as technology goes. It seems to be a little bit easier, but it would still be a hard road to go down for that, I think. Okay, so that's, again, we're going to see our circulatory system be affected the most in this one, and our levels of glucose are going to be really low in our cells. Okay, last but not least, we have pancreas injury. So this one's probably the one you guys know the least amount about. So this one was called troubles digesting. So we consider the pancreas an accessory organ to our digestive system because we don't actually have food pass through our pancreas, but we couldn't digest without our pancreas. Basically, other than insulin, our pancreas produces all the digestive chemicals that we need to break our food down. If we can't digest our food, we can't absorb it into our cells or into our bloodstream because it's going to be too big, and then we can't get it into our cells where we need it. So pancreas injury is a huge one. This one's going to directly affect our digestive system. Okay, so lower than normal digestive enzymes produced due to this injury to the pancreas. So the pancreas is responsible for making all of the chemicals that digest our food. The patient will have lower than normal numbers of amino acids and glucose in their blood and cells because their food was not properly digested and not absorbed. So basically, we eat it, comes into our body, but we don't break it down and use those nutrients, and then it just leaves our body, okay? So we don't get anything out of the food we eat. So we're gonna see, again, our circulatory system's gonna be affected, definitely our digestive system's affected in this. And we won't see a whole lot of levels of all the nutrients we need in our cells or in our blood. Okay, I forgot to change this one. This one would have to be regulated by chemicals. Regulated by diet and medicine. Okay. All right, moving on. So what I did is I took a screenshot of a healthy individual. You guys can kind of compare this to your model from the warm-up and see how close you guys were to fixing your warm-up model. Okay, but I wanted to show you guys this so you have something to look at the next two slides with. So what you're going to do is in class, the kids discuss this with their partner, but at home, you guys are going to use the draw tool to just kind of do a little matching with this. Okay, which condition is this? I have two models for you guys. One represents anemia and one represents asthma. So I want you guys to take a second, pause this, figure out which model you think belongs to anemia and draw a line, and which one belongs to asthma and draw a line. So one picture for each of those to figure out which condition goes with each model. Okay, so pause and do that and then come on back. All right, so what you guys should have looked at is obviously if we're talking about anemia and asthma, we're looking at the amount of oxygen levels in our blood. So if we compare this one, what we see is not a whole lot of oxygen in our lungs, therefore not a whole lot of oxygen in our circulatory system or our cells. Okay, that particular model represents asthma because remember you can't breathe as easy, so you're not getting a lot of oxygen into your lungs. Okay, so this first one you guys should have marked as asthma, which leaves this one to anemia. So you're breathing in normal amounts, as you guys can see right here, but because you don't have as many red blood cells, notice the low oxygen in the circulatory system and in our cells. Okay, so that second one is going to represent anemia. Okay, all right, moving on. The next one looks at glucose. So one of these is diabetes, one of these is pancreas. So go ahead, take a second, pause this video, figure out which you think is diabetes and which is a pancreas injury. All right, so if we look at this first one, we're going to be kind of looking at the digestive, the glucose side of this. Okay, so we see two big differences here. Okay, first off, with our diabetes, what we see is we're not removing all that glucose from the bloodstream to put into our cells. So remember with diabetes, we don't produce enough insulin, which takes the glucose out of the bloodstream and puts it into our cells of the body or our glucose storage. So notice how the cells of the body and the glucose storage have no glucose in them, and that we have kind of high levels of glucose in our bloodstream. That represents diabetes. So if you guys marked this one as diabetes, you were correct. Okay, pancreas injury, you guys don't have the enzymes needed to break down your food or digest your food. So what we see is our starch is not being digested, our amino acids aren't being digested, and they're just leaving our body. So we don't have any glucose or any amino acids entering our bloodstream. no storage here of glucose, and no glucose or amino acids in our cells of our body. So this one would represent the pancreas injury. Okay, so if you guys selected that one as pancreas injury, you are correct. Okay, and with that being said, let's go ahead and move on to our next slide. Okay, you guys are going to go ahead and just review what you learned about whether you guys were home or in class the other day. So the medical condition I am learning about, that was the one you were assigned to read in your group of 4. So circle your answer there. It affects this or these molecules in that the human body needs to function. So circle all that apply. We just went over all of these. Okay, in the cells of the body with this condition, I would expect to see either fewer or more. And then what molecules? Oxygen, glucose, or glucose and amino acids than in a healthy body. Okay, so if we're talking about the cells of the body, what would we see less or more of in those cells? Okay, again, that should relate specifically to your condition that you read about in class the other day. Okay, moving on. This is where it kind of gets fun because this is where you guys get to collect data about what a healthy body looks like and what an unhealthy body looks like. And then you guys get to apply that to Elisa and see what's really going on with her. So the first thing you guys will do is you guys will collect data for a healthy body. So you guys will need the sim for this. Okay, you guys will choose healthy body. You're going to select yes, and then we're going to go to test. For this, we're going to see how much of these molecules our cells are absorbing and using in the body. So you're going to feed your body 2 corn, 2 fish, and 2 sandwiches, and that should give you guys a pretty good array of the types of foods and the types of molecules we need in our body. We're going to set our activity level to walk, which is where it should be at, and we're going to set our speed high so we don't have to wait too long for this, and then we're going to go ahead and press play. But you guys are going to collect your data from the graph view. So go ahead and click on the graph view. And while that runs, I'm going to show you guys where you're going to be collecting your data. I think if I exit off of this, it stops. Okay, you guys will be collecting your data on slide 18. So notice right here, see slide 18. So you guys are going to run this twice. And what you're looking for is this little box over here. These are the 4 pieces of data that you guys are collecting. So total molecules absorbed by the cells, you're going to look at how much molecules of glucose are absorbed by your cells, how much amino acids are absorbed by the cells, how much oxygen is absorbed by your cells, and then how much oxygen are we actually taking in per breath. So these are looking at these molecules and how they're getting, from either our lungs, our digestive system, into the circulatory system, and to our cells. Okay, this is just telling us how much oxygen is coming into our lungs every breath we take. Okay, so you're going to let it run for 200 time units. Remember, 200 time units really isn't seconds because we wouldn't have digestion occurring this fast. Okay, once you guys are done, you'll record your answers in slide 18. So first one here, you guys can click and type healthy body. We're going to go ahead and plug in 49 glucose absorbed by cells. So we had 49 come from our food through our circulatory system and into our cells. That's what a healthy body should look like. Okay, 61 amino acids. And this will vary every time you guys do it. So you're going to do 2 trials each. And 253 oxygen are absorbed. And finally, oxygen molecules taken in per breath is 25. So every breath we take, we're bringing in about 25 oxygen molecules. Okay, you guys are going to go ahead and run a second trial of that. So you guys will reset. And you guys will go ahead and do the exact same thing. Feed it 2 of each food item. Make sure it's set to walk. You guys can speed it up and then hit play. Again, let it run for 200 time units and record your trial 2 right there. I went ahead and did trial 1. You guys can use that same data. I'll leave it in there for you. Okay? And then what you guys will do is you will do the same thing for anemia or whatever your guys' condition was. So anemia, asthma, diabetes, and pancreas injury, you guys are actually going to need to collect all of this data. So your instructions for that are on slide 16. You guys will select the condition over here. So if you're doing anemia, you're going to go begin level, yes. Test it, yes. Feed it the exact same things. We want to make sure it has the same food as the body, the healthy body. And then you guys will go ahead and do 2 trials of anemia, 2 trials of asthma, 2 trials of diabetes, and 2 trials of pancreas injury. And you guys will record just like you did, okay? So I want to go ahead and show you guys one example of anemia. And so I'm going to say same activity level. I'm going to change my speed, and I'm going to let that run. Again, remember that when I let it run for 200 time units, we're not actually letting it run for 200 seconds, because if we ate all of that food, it would take far more than 200 seconds to digest it and be able to use it for metabolism. Okay, if we're looking more realistically, it might be more like 200 minutes. Okay, but even that is a little bit small as far as time goes. So again, we're about halfway there. I'm running our first trial of anemia, which again, you guys are more than welcome to use this data. And from there, you guys are going to be able to compare that to the healthy body. So I'm going to kind of show you guys what this looks like and show you guys what you're doing in the next part of this. So 200 is coming up close. You guys can see that I've had to actually take my activity level down to resting because I don't have enough energy. Okay, so here's my 200 seconds. I'm going to go ahead and record. All right, 43 glucose. My amino acids were 51 and my oxygen was 147. And the oxygen molecules taken in per breath, which is important, is again about 25. So that seems pretty normal. Okay, so you guys will finish collecting all of this data, do anemia, another try, do asthma, 2 tries, diabetes, 2 trials, and pancreas injury, 2 trials. And then the next part of this is right here. Use your draw tool to highlight any areas that are way higher or way lower than the healthy body data. So I wanted to collect some anemia data so I could show this to you guys. Okay, so if I look, a healthy body is about 49 glucose molecules absorbed by the cells. In anemia, we only saw 43. That is not enough of a difference to say that, you know, there's some kind of problem with the amount of anemia absorbed or the amount of glucose absorbed. That's actually pretty close to normal. I could run that again a second trial and have it be a little bit higher. It could be 51. You guys will need to obviously look at both of your trials. What you're looking for is a major difference, either too high or too low. Let's look next at amino acids. So if we just compare our one trial of the healthy body to our one trial of anemia, again, it's only a difference of 10. We could again run the second trial and have it be more than 61. Okay, so always take a look at both trials to compare them. That's not a huge difference. Let's look here though. 253 oxygen molecules absorbed by the cells versus only 147. That is a huge difference. So you guys would highlight that. Okay, that is something to be concerned about. This one, exactly the same, so we wouldn't highlight it. Again, it's important to look at your guys' second trial too to make these decisions, but you're really looking for a huge difference in these. Okay, so what I want you guys to do is use your draw tool and go through and highlight all the ones that you find a huge difference for. So compare your glucose for asthma, your amino acids, your oxygen, and the oxygens per breath for both your asthma trials. Do the same for your diabetes and the same for your pancreas injury. What you're looking at is the differences in those molecules. Okay? All right. Once you guys have done that, then let's find out about Elisa's test results. So on slide 20, you guys will see Elisa's test results. I put in some data for a healthy body for you guys so you can compare. Here's Elisa. So you guys are going to do the same thing. You're going to highlight, okay, of her total molecules absorbed by the cells. Would you guys highlight 19? Okay. Do you think it's enough of a difference that it's concerning to you if you were a doctor to say, yeah, that's an important piece of information? Okay, 64 versus 54 for amino acids, 258 versus 273. Do you think that's enough of a difference? Or 25 versus 25? Okay, what you guys are going to do is once you highlight your results here, the ones that you think matter, you're going to kind of compare them back to your conditions. Which one looks the same as Elisa's data? Is it anemia, asthma, diabetes, or pancreas injury? Okay, so compare what you guys kind of came up with as your results. Okay, then answer these questions. What happens to glucose in the body of a healthy person? Think about, again, what we learned in those first couple slides between the warm-up, the wrong model, the review of the 4 conditions, and then moving on to comparing a healthy body to those models of the 4 conditions. What happens to glucose in Elisa's body? So take a look at her data. Okay, what are we not seeing? Where are we not seeing glucose at? Okay, where are we seeing glucose at? Okay, what happens to oxygen in the body of a healthy person? Again, review those earlier points. And what happens to oxygen in Elisa's body? Again, review back to those points. Okay, and then finally, which condition do you think Elisa has? Circle anemia, asthma, diabetes, or pancreas injury. At this point, really, you guys can narrow it down to 1. And which of Elisa's body systems are affected by this condition? Think about what I went over in that review today. Which ones are we talking about? Which molecules that the human body needs to function are affected? Again, circle all that apply. Think about that review that we went over today for those 4 conditions. And finally, explain why you think Elisa has this condition. Use numbers directly from your data table to support your answer. So if you guys aren't using numbers from your slide 18 and your slide 20 data tables, you're just really not doing what I asked you to do on this question. So make sure you guys pull in some numbers. What are the ones that are normal? What is Elisa? How does she vary? And how does that compare to the conditions that you guys see that you tested here? Okay, once you guys have done a good job explaining that using all the numbers that are relevant, you guys will fill out the wrap-up. Any questions, yes or no? If yes, type them below. If no, you can leave that blank. And then 4, 3, 2, 1, how do you think you did? You are all done, and you can go ahead and hand this in. Sorry, that's a lengthy lesson. It needed a lot of explaining, and I hope you're having a great day. Bye.